All right, AGS1. Today we're going to talk more about systems of equations. The essential question for the day is how can we use the elimination and substitution method to solve systems of equations? So, we're going to do a bunch of examples today about how to use this elimination and substitution method. And when it comes to an assessment, if it says to use a certain method, you need to show that method. But if it doesn't say that you have to use a certain method, you can use whatever method seems most appropriate to you. Both methods will always work. It's just that one might be easier than the other sometimes. Okay, so the elimination method. If I look at this system of equations, which first of all, a system is just means that there's two variables involved. So here's an x and a y, and then there's a second equation with an x and a y as well. So to use the elimination method, you have to make the coefficients match up and be opposites of each other. So I'm going to zero in on the fact that -2 and this negative up here, that I could multiply the top by a -2 and it would make the top coefficient +2. Here's what I mean by that. We're going to take all of this and multiply it by a -2. So that -2 is going to get distributed here, here, and here. I'll just go ahead and rewrite that over here. So -2 times -x would be +2x. -2 times -7y would be plus 14y. And then -6 times -2 would be 12. Now this bottom equation, I'm not going to change at all. I'm just going to copy it straight over here. So this is -2x minus 6y equals 4. Now, the beauty of the elimination method is once you do, change one or both of the equations, you should have a pair of coefficients that are opposites of each other. So a +2 and a -2. This means that you can add up the equations and this part of them will eliminate. Thus, the word elimination, because you're eliminating a variable. So here, 2x and -2x is a 0. Then 14y minus 6y is an 8y. And then 12 and 4 is 16. So the 0 plus 8y, 0 plus anything is just itself. So you get 8y is equal to 16. And then you divide both sides by 8. And you get y is equal to 2. Now, with any system of equations, once you get one of the variables, you're going to have to plug it back in to one of the OG equations to figure out the other variable. It's really up to you about where you plug it in. I think I'm going to take the original right here and then rewrite it, but instead of y, put a 2 in its spot because we just figured out the y. So we get -x minus 7 times 2 is equal to -6. Then to solve this green equation, I'll first multiply, so we get -14 is equal to -6. Then we're going to add 14 to both sides. So we get -x is equal to +8. And then divide both sides by a -1 to get rid of that negative. So we get x is equal to -8. Now, you guys, these two things are our answer. X is -8 and y is 2. But that's an x and a y on a graph, which means that your final answer is going to be a coordinate, 2, -8. And that is the answer to the system. That's the elimination method. Now we're going to go substitution method. The way substitution works is that you have to get a variable by itself. So you have to solve a variable first. There's a few different variables you could solve for here, but I think the most obvious one to me is trying to get this x by itself. So if you subtract 3y from both sides, you get x is equal to 4 minus 3y. Now, what we're going to do is take this 4 minus 3y, and then we're going to substitute it into this x spot right here. So I'm going to rewrite the bottom equation, but instead of x, I'll put in a 4 minus 3y. So we get negative 3, then a big parentheses, plus 7y is equal to 20. So I just rewrote the bottom equation, but instead of x, I put a big gap because I'm going to make x what I solved for in the first equation. So I'll put a 4 minus 3y in there. Now we need to try to get y by itself. So we're going to distribute the negative 3. Distribute the negative 3, and you get negative 12 plus 9y plus 7y is equal to 20. So then we're going to add 12 to both sides. Oh, also, we'll do two moves at once. The 9y plus 7y is 16y. So we get 16y is equal to 32. Divide both sides by 16. You get y is equal to 2. So we just solved for one of the variables. Just like with both methods, with substitution and elimination, once you get one variable solved for, you plug it back into one of the OG equations. I'm going to go with this one right here, and I'm going to rewrite it as x plus 3 times 2, because we figured out that y was 2. So that's x plus 3 times 2 equals 4. So we get x plus 6 equals 4. Subtract 6 from both sides, and we get x is equal to negative 2. So our final answer is negative 2, positive 2. So that is the substitution method. Get a variable by itself and then plug it into the other equation. Here's another solve with substitution. It's up to you about which variable you solve for, but this x is already close to being on its own. So I'm just going to rewrite that one as adding 3y to both sides. So you get x is equal to 5 plus 3y. Then we will take this top equation and rewrite it, but instead of x, I will leave a big gap there because we're going to substitute in the 5 plus 3y. So you leave your gap, and then this part right here gets plugged into this spot. So you're replacing the x with 5 plus 3y. Now let's solve this equation by distributing the 3. So we get 15 plus 9y plus 3y is equal to 15. Then we can add the 9y and the 3y together, so we get 15 plus 12y is equal to 15. Then we can subtract 15 from both sides. We get 12y is equal to 0. Now, some people might hit this spot and be like, oh no, I did something wrong. It shouldn't, can I divide 0 by 12? It's totally fine to have 0 as an answer. 0 is still a number. You can divide both sides by 12 right now, and you get y is equal to 0. So that's part of our answer. To find the other part, we need to rewrite one of the original equations. So I'll do that over here and say x minus 3 times 0 is equal to 5. So we get x minus 0 is equal to 5. So we get x is equal to 5. So our final answer, 5, 0. Next up, another solve with substitution problem. Okay, well, we have to get a variable by itself. So I'm thinking the y is close to being isolated. So we'll add 6x to both sides and get y equals negative 5 plus 6x. Then we can rewrite the bottom equation, but instead of y, we'll replace it with negative 5 plus 6x. So we get 6x minus negative 5 plus 6x is equal to negative 7. Then you can think of this negative right here as a negative 1 that needs to get distributed to both of these things. So that 6x I'll just drop down, and then we'll get plus 5 minus 6x is equal to negative 7. Then a positive 6x and a negative 6x cancel out, so we get 5 is equal to negative 7. Now, you guys, all the x's disappeared. We have no more variable to solve for, and we get this funny statement of 5 is equal to -7. Now, 5 is equal to -7 is not true. So you might be like, wait a minute, what is happening? This means that there is no solution to this system. So if you're trying a substitution or an elimination method and all the variables go away, and then you wind up with a statement like this where it's something that's not true, 5 does not equal -7, that means there's no solution to the system, and you can stop right there. Just say that your answer is no solution. Now, solve with elimination. Back to elimination, you need to make a set of coefficients be opposites of each other and the same number. A -3 can turn into a -6 real easy by multiplying the entire top by 2. So that means we get -6x minus 6y equals -18. So I'm distributing that 2 to all three things. And then the second equation I won't change. I'll just move it over. 6x plus 6y is equal to -18. And then we can add the two together. Oh, sorry, that's on top. That's a positive 18. I messed up that. Yeah. Now, you guys, another special case. If we add everything together here, 6x and -6x cancel each other out, which is great. But then 6y and -6y also cancel each other out. So we get another 0. And then 18 and -18 also cancel each other out. So we get 0 is equal to 0. So once again, all the variables went away. So this is another special case. But if you look at this statement right here, 0 equal to 0, that is true that 0 is equal to 0. So that means our answer is infinite solutions. So if everything cancels out and you get something that's not true, like 1 equals 5 or something like that, there's no solution to the system. But if everything cancels out and you get a statement that is true, like 0 is equal to 0 or 5 is equal to 5, then it's infinite solutions. All right, you guys, let's dig into the problem set for the day. I can certainly help, so ask me questions.